Okay, our speaker tonight is Geoff Pofahl. Geoff is a clinical assistant professor in the Department of Information Systems at Arizona State University, where he currently teaches graduate level Python classes. He also has significant industry experience with data science and machine learning. I'll turn it over to Geoff. But we can't hear you.
Let me go ahead and share my screen. And let me just say, so we're going to talk a lot about AI, obviously, and the subtitle for the talk was Implications for Coding. And I didn't want that to be a clickbait title. We're definitely going to get to that. But a lot more of what I have to share is going to be basically framing for what I think those implications are going to be, because I think it's important that right out of the gate, we remind ourselves to be humble about what's going to happen. A few months ago, I was listening to a podcast and I heard this quote and I thought, I've got to write this down because it's one of the most honest things I've heard in all of the chatter about what's going on with AI. And it was this quote from David Sachs, who, if you don't know who David Sachs is, he's a venture capitalist out in the Bay Area. And while they were discussing all of the developments with generative AI, this is what David said. Basically, hey, we're on a bullet train. We don't really know where we're going to land. And one thing that I think is interesting, if you spend any time listening to the experts, there are a lot of diverse opinions about the direction that this is going to go. There are some experts who don't think there's anything to worry about. AI is just a tool. Humans are adaptable. We always find a way to still be needed. And they say, don't worry. There's others who believe that AI is an existential threat. So you'll find folks on that entire spectrum. Where am I at? I don't know. I think that the reality will be somewhere in between. But I think anytime you hear people speaking about what's going to happen with any degree of certainty, that we should be skeptical and realize that there's probably another expert with a different opinion. So instead of focusing on specific speculations or predictions about what I think is going to happen, instead, for me at least, I find it more productive to talk about context. Where have we been? What do we actually know about what has happened in the past? What is happening in the present? Are there any high-level frameworks that we can bring to bear to help us understand what might happen? And then again, there's a big capital M at the beginning of that word might, because we don't really know. So let's talk about some things that we do know. If you look back in time and study some history and measure technological progress just about any way you choose, and were to plot that on a chart, it would look something like this. And it would go obviously much further back than 1980. But it would look like this. And this is not my idea. There are much more intelligent people in the world who have done a lot of research to establish this, and I'm just going to refer to one of them, Ray Kurzweil. Some of you may not have heard of him. If you haven't, he's an AI scientist at Google, but he's more famous for several bestseller books that he has written and published. The one I refer to here, I highly recommend. It was published in 2005, and Ray does an outstanding job of looking into the past and looking at different ways to measure technological progress, and then measure what it looks like over time as far as how that progress evolves. And just about any way you cut that concept of technological progress, it ends up looking something like this. It's exponential, and in some cases, it's double exponential, okay? And let me just give you one example. Transistors on a microchip. So this is one that people talk about a lot. because we have data, at least in the 20th and 21st century. And going back to 1985, the most powerful microchip at the time was the Intel 386 with, a whopping 275,000 transistors on that chip. We weren't even at 1 million yet, but that was the best we had. Fast forward 15 years and we're over 42 million transistors on a chip, but we're still in the flat part of this curve. It wasn't until after 2010, we started getting into the billions of transistors being crammed onto a tiny microchip. So in 2017, AMD had a chip and we're approaching 20 billion transistors on a chip. And then just this year, Apple launched their M2 Ultra, and that thing allegedly has 134 billion transistors. Now, this is just one dimension. You could do this with megapixels on cameras. You could do this with hard drive space. You could do this with RAM. There's lots of different dimensions that you could look at to measure this. And this is just one part of what folks know of as Moore's Law. And there's actually a lot of chatter about Moore's Law being dead. Folks rightly saying, hey, there are physical limitations to how many transistors we can put on a microchip. This cannot continue. I'm not a physical scientist, so I can't really speak to that. That makes sense to me. But I also believe there will probably be some sort of breakthrough that allows this progress to continue. Maybe not in the same way it is going right now, but I do believe that there is historical precedence to suggest that we will find a way past these physical hurdles that we tend to run into. And this is something that Ray Kurzweil articulates very, very well in the book that I just referenced. And he talks about this construct of a technological growth curve. So basically, over time, what we see is there's some sort of breakthrough, some sort of new technology gets introduced, and it usually takes, kind of a ramping up period where folks are, getting to understand the technology, wondering what it is, and then you have early adopters, and then you start to have widespread adoption, and you get this period where there's this rapid growth, right? But then it starts to level off. Competition sets in, maybe there's government regulation, there's high adoption, and you get to the point where when everybody who can adopt the technology does adopt the technology, at some point, the benefits of that technological breakthrough start to level off, okay? And if there were never any additional breakthroughs, we would just continue on that flat line indefinitely. And there have been long periods in the history of humanity where that has been the case. Maybe the wheel was invented, and it was a long time before some other breakthrough was invented. But eventually, there is another breakthrough, and then we get another growth curve. All right, and they always tend to be S-shaped like this. And you may be thinking at this point, well, wait a second, Geoff, you just told us technological progress grows exponentially over time. This does not look exponential. I see some curves here, but if I were to put a trend line through this, that's linear. So maybe this isn't right. So let's back up. What Ray Kurzweil actually suggests is when we have these additional breakthroughs, those growth curves don't look the same that they looked previously. So instead of being kind of the same along the same linear projection, maybe we would have something like this. So the new growth curve is steeper. The amount of time that passes from the rapid adoption and growth to the diminishing returns, that time period becomes shorter and shorter as we move into the future. So if we were to zoom out, we might end up with something that looks like this. So here's a breakthrough, here's a breakthrough, here's a breakthrough, here's a breakthrough, and on and on and on into the future. And each time, the trajectory of the growth obviously gets steeper and steeper and steeper. I see somebody in the chat. Yes. Thanks, Carol. Okay. So the interesting question here in my mind, when I look at something like this, if you know, and again, this has been well documented that this has happened historically, I think the question on a lot of people's minds is, well, where are we on this growth curve? Are we here or are we here? Either way, there's some exciting things ahead. But the higher up this growth curve we get, because it is exponential in nature, we can expect more rapid development, more rapid changes, things that are harder for us to comprehend. Because, you know, just to give a public service announcement, I don't know if it's because we're hardwired to do this, but it seems that as humans, we have a really difficult time comprehending exponential growth. When we look ahead, we tend to think in linear terms. It's hard for us to comprehend exponential growth. And just to prove that to you, just to remind you of this, let me just give you a thought exercise. Suppose you're standing here and you're about to take 30 steps. And suppose each step you take is 1 meter. Okay, so you're going to take 30 linear steps. How far have you traveled? Answer's easy. You've traveled 30 meters. Okay, well, let's repeat this exercise, but now instead of 30 linear meters, suppose you travel 30 exponential steps. So your first step is 1 meter, the next step is 2, the next step is 4, the next step is, you see where I'm going. So how far will you have traveled after 30 exponential steps? And let me give you a hint. You're going to take at least one trip around the world. Put a number in your head and maybe prepare to be surprised. Anybody want to guess? Drop it in the chat if you think you've got a number. Here's the number. You're going to do 26 laps around the planet, okay? Now, this is just one example. This is just one illustration. I could give you more, but I'm just trying to remind everyone that and this is why I say when we're talking about AI and technological progress, anybody who talks about what's going to happen confidently, I think they're underestimating this phenomenon of exponential growth, okay? Also, let me just remind everyone, while we're seeing this exponential progress in the performance of hardware, simultaneously, we are seeing exponential reductions in the costs of computing technology, okay? So a common unit of measure that's used to measure compute performance is called a flop, floating point operations per second. And it's typically measured 1 billion of those, so a gigaflop. And it's just, to me, it's fascinating to think that in 1961, the cost to process a gigaflop was around 200 billion, and that's measured in 2022 US dollars, okay? Let me skip through some of this. I'm fascinated with analogies of how far it would, you would travel if you translated those measures to distances. But let's just skip to 2022. We can still measure the cost of computation in gigaflops. It used to cost 200 billion to process that much information. Now it costs a penny, okay? So again, all of this just to reinforce things are changing very, very fast, which makes it hard for us to know where we're going to end up. To put this in terms that I think we can all relate to a little bit more, just looking at the devices that we use. If anybody was around in 1997, the top of the line laptop at that time was a Gateway Solo computer. All right. And if we look at these two devices side by side, so on the right, let's just say we've got an Apple iPhone, let's say it's the 14 version. And these are all back of the envelope calculations, just FYI. It's pretty clear that the Gateway Solo had 166 megahertz of processing power. These new iPhones have multi-core processors. So the math The translation, you know, is it's not direct, but you know, my back of the envelope calculation said that basically the new Apple iPhone processor is equivalent to about 15,000 megahertz of power. Here's the RAM numbers. Here's the storage. Okay, how much did that Gateway Solo cost in 1997? You would have paid over $5,000 for that thing. I think most of us nowadays don't really pay much attention to how much we pay for our iPhones or Galaxies, because maybe we're paying $30 a month instead of handing out $2,000 to our cell phone provider. If we take that, and actually, if we look back and translate that 5,400 to current dollars, you'd be actually looking at more like $10,000 for that Gateway Solo. Now, if you take that 10,000 and figure out how much you're paying per unit of processing power, per unit of RAM, per unit of hard drive space, and then translate those prices per unit forward to your iPhone, if we were paying the same prices per unit of performance today that we were paying in 1997, that iPhone that you carry around in your pocket with your gum and your keys and your wallet, you wouldn't be paying $2,000 for that thing. You'd be paying more like 2.4 million. All right. So this example just kind of, again, it encapsulates everything we just talked about. We're seeing this exponential progress in the power of our compute resources, while simultaneously the costs are plummeting. Okay. And this is great because this puts very powerful devices in our pockets, at our fingertips. This allows us to be productive in ways that we could never imagine 20 years ago. And if things continue to go this way, and I'm curious to know what Ray thinks of this now, because this is a quote from that book that was published back in 2005, The Singularity is Near. I'm thinking Ray is probably in the process of updating this prediction, because at that time he said, hey, $1,000 of computing in 2050 is basically going to give us all devices where those devices have compute power that exceeds the processing power of all human brains on Earth. I'm guessing he's got a new book coming out next year called The Singularity is Nearer. And I'd be willing to bet he's probably updated this prediction. Someone told me once when I presented this quote, they're like, well, you know, Geoff, this could happen. This could actually happen in one of at least two ways, right? Computers either get more powerful, or it could just be that humans become less intelligent, right? Hopefully it's the former. Okay, so all that being said, so that's the background here. Why does it seem like we're only taking this seriously now? Because I don't know about you, but I don't remember, and I've been working in this field for a while. I've worked as a data scientist, as a machine learning practitioner. I helped build products at IBM that were marketed as AI products. And at the time, those of us building those products, there was not anywhere near the level of excitement that we've been experiencing in the past year. So what's different? I mean, AI has been around for a while, right? So let's talk about this for a minute. I think it's important looking back to realize that the previous AI applications were what we are now referring to as weak or narrow AI. And it's kind of insulting that we're now calling that AI weak, because I promise at the time we weren't calling it weak. That was not good marketing, right? It was just AI. But in light of recent developments, we're now looking back and saying, oh yeah, well that was weak AI. Well, what do we mean by weak AI? Let me just give you a couple examples. Autonomous vehicles, certainly not a weak application, but it's very focused. The machine learning that goes into autonomous vehicles is focused exclusively on being able to drive cars. You probably wouldn't use the same machine learning algorithms that you're using to drive those cars. You probably wouldn't use that same technology. You'd use parts of it, but it would be focused in a different way for another application. So for instance, recommendation engines. When you go onto Amazon or Netflix or other online services, they're always putting things in front of you. Instagram is putting ads in front of you. All of this is driven by narrow AI, where they're trying to predict what they think you want to see, okay? Another application of narrow AI would be supply chain optimization. Where do we put our warehouses? Where do we put our distribution centers? What are the optimal routes for our drivers to take to minimize the cost of delivering merchandise to our customers, et cetera? All of this is driven by weak or narrow AI. One more example that I think we all benefit from is credit card fraud detection. Every single transaction that you make with your credit card is instantly being fed through a machine learning classifier that is basically asking the question, is this transaction legitimate or is it fraudulent? And if it's potentially fraudulent, they're going to block it. They're going to send you a notification. I think most of us have been through that routine a few times. But I've noticed over the years that doesn't happen nearly as often as it used to. Why? Because that narrow AI is actually getting better. I also think it's important to point out, so those are some examples of weak or narrow AI. The precursors or the foundations of what we're now calling generative AI have been around for quite a while. And those are artificial neural networks. But it turns out until, the last few years, those artificial neural networks, they weren't that good. People saw the promise, but no matter how big we made them, the predictions just weren't reliable enough for folks to get excited about it. And they kept trying to make these artificial neural networks larger and larger and larger. But then you run into limitations with being able to actually train those neural networks. They became too costly to train. Well, there was a breakthrough. In 2017, there was a paper. I encourage anybody who's interested, you can go read this paper. A bunch of engineers at Google published this paper. Attention is all you need. Well, basically, it was a breakthrough in these deep learning artificial neural networks that significantly increased the efficiency with which those models were able to be trained in very specific locations of the network. And this just opened up a massive opportunity for the developers of these large models to be able to expand them to sizes that they could never, ever comprehend expanding these models to, which means we're now building models. And these numbers I'm going to show you here are rumored. We don't know for sure. OpenAI has not told us this, but there have been some leaks. And so people have speculated GPT 3.5. So this was the large language model behind ChatGPT. Folks have approximated that there were roughly 150 billion parameters in this model. And GPT-4 has been estimated to have over 1 trillion parameters. And because of the size of these models, something magical happened. And I think we all experienced this in the last year. As a teacher at ASU, I teach undergrads and grad students. Last January, I was teaching an undergrad analytics course, and it was all focused on Microsoft Excel. So students are typing in VLOOKUPs and learning how to use pivot tables. One day in class, I took one of their assignments, dropped it into ChatGPT and said, hey, I don't know how to do this. Here's my data. It starts in cell A2, and it goes to cell, it's got columns going out to H2, and then here's the length of my data. Can you write some formulas for me that will do this? And it basically proceeded to do the work that these students were a lot of these students were struggling to figure out how to do. And of course, ChatGPT made quick work of it. I saw a lot of faces that looked like this. I had students approach me after class and say, oh my gosh, I'm like about to graduate and I don't even know what I'm going to do now. So, and that wasn't the intention. The intention wasn't to scare anybody. And not all the faces look like this. And oh, by the way, all the images in this presentation are all AI generated. Okay. None of these images are real. I saw other faces that look like this. These are the faces of students with ideas. Students looking at this technology saying, oh my gosh, I've had this brilliant idea I've been sitting on for a long time, and I thought I didn't have the technical skills to be able to pursue that idea. Now it looks like maybe I don't need the technical skills to pursue that idea, because now it looks like there might be the promise of tooling that allows me to pursue these ideas that I never would have pursued before. And I'm going to show you guys some examples in a minute of some things that I've seen students actually do with this technology. So again, back to this question, what is different this time? Isn't ChatGPT, Bard, Claude 2, aren't these just language models? Aren't they just predicting the next word? It's just statistics, right? So it is true that these models know human language, okay? And they know human language very, very well. But they also know compute languages. I don't do a lot of coding. I teach a Python class, so I know Python pretty well. But I don't know Java. I don't know C++. But I know that the generative AI models know. In fact, I've had experiences, and maybe some of you have experienced this, where GPT-4 has introduced me to coding syntax that I didn't know existed. So just one anecdote, for instance, once I asked it to produce a diagram for me, and this was an early version where I knew it would not be able to produce a diagram for me. This was before plugins became a thing. And it came back and said, I can't draw a picture for you, but instead, I'm going to write some SVG code for you. And I thought, well, what is SVG? I've never heard of SVG. So it taught me about scalable vector graphics. And it says, I'm going to write this code for you. And what you need to do is copy and paste it into a text file, save it as an HTML file, and then you can run it. It'll render in your browser, and that will be your diagram. Now, the diagram wasn't great, but it was directionally correct. So we know that these models know computer programming. And what's the big deal about this? Well, the big deal about this is we now have a tool, being the large language models, because it knows both human language and computer languages. It can serve as an intermediary between those. It can, in theory, be the organizer and the orchestrator of a host of potential narrow and weak AI agents that are performing very, very specific tasks. And the large language model is basically serving as the manager of all of that, okay? One little aside here, these images that were generated by Midjourney, I think it's really fascinating. I'm talking to a group of women who code, and every time I ask Midjourney to basically produce a picture for me of generative AI in human form, it always gives me a picture of a woman. I don't know why. I find that fascinating. Maybe if AI ever takes over, maybe this means that those of you who are women who code, you guys are in a great position to relate to the AI. What I was talking about here, where the large language model is serving as basically an orchestrator of a collective of agents, we're already starting to see hints of this. So some of you may have heard of AutoGPT. So it's an open source program. You can find it on GitHub, where basically folks are trying to figure out how to patch together a series of weak AI agents where some sort of task can be broken down into steps by the large language model, and then those steps can be looped through, and large jobs could be performed in an iterative way using this collective of AI agents. We're now starting to see similar things with Microsoft. Their research division recently released AutoGen, and they just released this as open source. So it's freely available to anybody who wants to use it. As best I can tell, it seems similar to AutoGPT as well. So what does this mean? So I asked AI what this means, and this is what it told me. I don't know what that means, but I translated it to mean if you can describe it, you can build it. If you can describe it in human language, you can do it, whatever it happens to be. And that's very empowering. So let me just share a few anecdotes of what I've seen, and this is literally just in the last 3 months. As I've been teaching graduate business students Python and machine learning, a lot of these students have no technical training at all. A lot of them were very intimidated when they got into a Python class. It was the first time they'd ever written any code at all. But for many of them, they quickly realized that probably the most important thing they learned in my class was how to run Python, just how to run it. Because they learned very quickly that, even though I emphasized with them, hey, look, it's important to pay attention to syntax to the extent that at some point in time, something might break and somebody has to fix it. And if you don't really understand how the code works, you're going to be at a dead end, right? But let me just show you a couple examples of some things that happened. So I had one student, very creative student, totally new to Python, but he decided he wanted to use generative AI to create a joke book. So he created a company. He worked with ChatGPT to come up with a bunch of jokes, a bunch of images, and then he put all of this in a Microsoft Word document. And then he was looking for a publisher, or I should say a printer. He actually set up a publishing company himself. But as he was negotiating with the printer overseas, he was busy trying to format this document so that he could, obviously when he found a printer, he'd be able to send off the manuscript and get 500 prints of this book so he could start selling them on his website. Well, he quickly realized that just the task of formatting a massive Microsoft Word document was a much bigger job than he wanted it to be. I mean, just simple things like organizing page breaks, okay? Well, in the middle of doing this light bulb went on in his head, and he thought, I wonder if there's a Python module that could help me format my Microsoft Word document. So he asked ChatGPT, and sure enough, he got a affirmative. Yes, there is. This is how you do it. And within minutes, his book manuscript was formatted perfectly. He basically just had to point the script to his file and check the work. It did exactly what he had been struggling to do himself for many hours. And he was able to send his manuscript off to the printer that same day. So just one example. One more example, there's a student in my class who runs a fitness apparel business in Taiwan. And again, not a technical person at all. My Python class was the first time she had ever written any code at all. For her online business, every month she would do a performance report where she would probably download a file from Google Analytics, and she'd look at things like cost of goods sold, a bunch of other metrics, and it would take several hours to do this report in Excel. Well, similar to this other student, she thought, I wonder if I could do this in Python. And she figured it out with the help of a large language model, because she was able to describe to the AI in human language what she wanted to do. It was able to interpret her description into working Python code. And this was music to my ears. She posted this on LinkedIn, that, she's now able to effortlessly create this report. Whereas, previously it would take her hours to do this. Now, the thing that I think is interesting to think about here is these are not coders, right? These are business students. These are MBA students. But they now know enough about code, and they know that, hey, there's this intelligent large language model that knows syntax better than I will ever be able to learn it. And if it does something wrong, maybe I need to go find an expert at some point in time. But they've also learned very quickly, if it produces code that doesn't work, I can just copy that code, paste it back in and say, hey, this doesn't work. Can you find what's wrong? And 9 times out of 10, it will find a mistake and then it will fix it. Okay. So why am I telling you guys this? I think that there might be a flood of people entering the market who think they know how to code, or they are going to attempt to code with the help or with the aid of generative AI. And I think, well, there's a number of things that could happen, right? Some might say, well, hey, this might be competition for those of you who have day jobs coding. I would argue in the short run, it actually might give you guys more to do, because again, there's things that are going to go wrong. It's one thing to apply this type of method to a one-off job where you only have to run it once, but to actually do something in production that's going to be stable, that's a different beast. And I think a lot of you know that. But I do think it is going to raise awareness of how important coding skills actually are. And it's giving these more business-focused colleagues greater awareness of what's possible. All right. So a byproduct of that might be greater appreciation for what you do as a developer. This has affected me. What you're seeing here is an email that I produced using a Python script. Basically, I used the OpenAI API to build a program for myself that would help me auto grade or evaluate my student submissions. So I had 200 Python students who were turning in Jupyter notebooks, and then a 5-minute transcription where they would turn on their Zoom camera. They would talk about what they did, what worked, what didn't work, what they understood, what they didn't understand. And they dump all of that into a text document, and that was their homework submission. Well, as you can imagine, that's a lot of text. It would be anywhere from 10 to 16 pages every single week for every student, 200 students, all right, for an 8-week course. I don't have time to evaluate that, but large language models do. So I was able to create a program that would loop through these submissions with a rubric that I provided and check for completion. So my initial round of this, I'm not awarding points. It's basically, these are participation assignments. I'm still doing a bunch of testing on how well GPT 3.5 or GPT 4 can actually consistently and accurately award points based on a detailed rubric. So that's a work in progress. But the fact that I was able to do this every week for 200 students, it would take about 30 minutes for this to run. It would send the feedback to their email directly. How much did it cost me to run this? $2 to $3 every time. That's a great investment, okay? This is another important thing to think about, because while I think a lot of big companies are going to be slow to move on adopting AI, what's going to happen when we see the next generation of startups come from a scenario where venture capitalists are going to them and saying, hey, you're telling me that you need $50 million and a year to develop a minimum viable product? I don't think that's true anymore. Here, I'm going to cut you a check for $1 million instead of 50 million. I think you can do that same minimum viable product with 2 or 3 people, okay, in 6 months because of AI. Once we start to see more and more companies built in that way, I think that's going to start to put more pressure on big companies to take this more seriously as well. Okay, let me, for the sake of time, let's talk about what this means for business. And I want to give you guys a framework that I get from this book called Prediction Machines. It was written by some economists up in Canada. And I think this is a really, really helpful framework to use when we think about the implications of AI. So the first thing to realize is you can think about AI as, what does it produce? It produces a prediction, okay? And there's a market for prediction capabilities. So in economic terms, you've got prediction supply, and that's our supply curve. It's always sloping up, right? As the value of the prediction goes up, the suppliers want to supply more of it. And then there's a demand for prediction, okay? And the relationship is opposite there, right? As the price of it goes down, more people buy those prediction capabilities. Hopefully you guys have all seen supply and demand curves before. And then there's an equilibrium, okay? So it's important to remember that AI prediction alone is not an action, right? If I'm a doctor and you are a software developer who happens to know some machine learning, and you build a prediction model that can help me with diagnosis, and you wrap that in a really easy to use user interface, and you bring that to me, okay? Well, all right, your model might be making a prediction about what a diagnosis should be, but ultimately, who makes the decision? Who takes the action? I do, okay? Not the prediction, all right? That's just an input into an action. And it's important to think about human judgment as having its own market, okay? In fact, human judgment, you can think of that market as being a complement to the market for prediction. So we might have something that looks like this. Here's the market for human judgment, and the equilibrium, the supply and demand for human judgment, is determined by the prediction market. So there's our equilibrium for prediction, and that actually helps establish the market for human judgment, all right? So we've got supply of human judgment, demand for human judgment. What happens when prediction becomes ubiquitous? When it's everywhere? So the supply curve for prediction shifts out. Well, that's going to affect the market for human judgment. That's going to cause the demand for human judgment to shift out, okay? Because again, prediction alone is not action. We need humans to be able to evaluate those predictions and say, okay, that's a good prediction, that's a bad prediction. What are the consequences of being wrong? Can we bear the cost of those mistakes, et cetera? So if you're in the market for human judgment, if you have good human judgment, you're going to be extremely valuable, right? I mean, check this out. In this scenario, when the demand for human judgment shifts out, the value of that service that's provided by humans actually becomes much more valuable than it was before. So to summarize all this, supply of prediction goes up, price of prediction goes down. We're seeing this happen right now. Prediction is now everywhere, which means we need humans to increase their judgment capabilities, because demand for that human judgment is going to be at levels that we haven't seen before. And so the value of that judgment is going to go up. So in the short run, and I just want to emphasize short run, because in the long run, like, all bets are off. I don't know. But in the short run, at least, people with critical thinking and good judgment, I think, are going to be in extremely high demand. How does this apply to those of you who are coders, who are developers? I would encourage you, don't just think in terms of syntax. Yeah, that's a skill you need to know, right? But think about the business. Think about this. Are you an employee who needs to be told exactly what to do, right? If you're developing front ends, do you understand the business that you work in enough to be able to be proactive about making suggestions? Or are you waiting for a product manager to come and say, hey, I want you to change this button. Hey, I want you to change this color. Or are you part of the strategic discussions? If I was in that situation, I would be thinking about how to move more in that direction. More things to think about for coders. Syntax. How important is syntax going to be in the next few years? I don't know. I mean, if we look at the history of syntax, we've already been evolving to higher and higher levels of abstraction. right? Like I know computer science purists, some argue that Python isn't even a real language, right? It's too high level. But that seems to be the trajectory, right? Big picture thinking, platforms and architecture. Are we gonna be at a point where it's actually more valuable to be able to write high quality pseudocode where you can clearly envision and articulate what an entire system needs to look like, as opposed to being focused on specific languages? My guess is that this is where things are headed. Again, I don't know exactly what this means in the long run, but I am running out of time, so I do want to pause and just say, hey, what are you guys' thoughts? I mean, I'm a business professor. Some of you are coding on a daily basis. Like, what do you think about this? What are your questions? I want to hear from you. You guys still there?
Yeah, I have, I don't know if it's a question or a comment. Can you guys hear me okay?
Yep.
Okay, cool. So I'm going to be entering my 3rd year of study in computer science. So I'm kind of like right in the middle of all this stuff happening. But I had an exam earlier this month, and I'd studied all this stuff about kind of like the concepts and like how this language differs from other languages, and like why you might want to use Rust was what, because of the memory management, like what types of systems it would be good for. But then the exam was all syntax. And I was like so disappointed because, I just, yeah, like you're saying, I just don't really feel that's like where the value is, but like someone being able to decide what are the different options for languages we could use to build the architecture. Like to me, that's a more valuable skill than just like memorizing syntax. So that was very disappointing to me, but I'm hoping that, some of my other classes were different, but I'm hoping like that critical thinking piece of it is like more emphasized. We can kind of combine, kind of an understanding of the mechanics, like what's actually going on, and then kind of layer on the critical thinking and not having to worry so much about the middle syntax, I guess.
Yeah, no, that's a great point. And I think it's important to acknowledge, I mean, there are people who would listen to what I just said and would vehemently disagree. This is an ongoing debate. I'm just one opinion. My advice that I've been giving to students is, hey, you're going to have some classes, you're going to have some situations where, the focus is going to be on, you got to know the syntax, right? Well, okay, for the sake of that class, you got to do what you got to do, right? But I think as far as big picture in the long run, we already know the trajectory, right? Like how many of you could sit down and write binary? How many of you are writing compilers, right? Like the history of this field has been just more abstraction, right? So why is this any different? It's no different now, right? The abstraction is just, it's getting to the point where, again, we can just describe things in human language. And yes, we do need to acknowledge that, hey, even if the large language model can write the syntax for us, there does need to be some subject matter experts at some point in time who can help debug things if the AI goes off the rails and can't do it for us. But I do think we need to realize that is the trajectory. And I think the skills that are going to be timeless are going to be those higher level critical thinking skills, understanding the big picture, understanding what can go wrong, so that if the AI produces something that's wrong, you'll be that intelligent human who can say, hey, I know everybody thinks this is working, but actually, I don't think it really is, right? I mean, that takes some serious subject matter expertise to be able to discern that. A beginner wouldn't be able to do that. I mean, I only know that because I've done a lot of machine learning, and it's really easy for somebody to go into ChatGPT and say, hey, here's my data. Can you build a random forest model for me to predict this thing? And here you go. It does it in like 10 lines of code. And somebody has a prediction model and they think that they have a superpower. And I look at it, I'm like, yeah, but you didn't think about the confusion matrix, right? Which basically articulates the different types of mistakes, your false positives, your false negatives, what are the costs to the business? And you know, you've got this person saying, oh, I didn't think about that. Well, of course you didn't think about it because you haven't done this before, right? So we're still going to need those people. And I got to believe it's going to be the same thing with software development.
Yeah,
Any
I
other
think
thoughts, questions?
I I think that there is something like, especially with like knowing the problem that you're trying to solve. Because even like in my job, it's a ERP. Uh, and so like sometimes the code technically works, sure, but it can be like, okay, but you can't just I'll just say like edit the cost of inventory or changing things like that because it has like business ramifications if you start like you have to know the whole process and the actual problem. Yeah, like how you said, it's they're not it's not gonna know that. You need the subject matter experts to do that.
Mm-hmm. So I'm
Um,
curious, for those of you who are in the code on a regular basis, how many of you are actively using either Copilot or any other type of generative AI as a coding partner? Is this as common as I think it is?
Carol?
I could speak to it a little bit, but also go ahead.
Oh, I was just reading in the chat that Carol said she has tried Copilot via code. Please continue.
Anybody?
Yeah, so I've been coding in Silicon Valley for like 12 years now. I was working for a pretty large consulting firm, and just less than a year ago, we were basically advised not to use Gen AI for coding out of concern for the many customers we serve. They just wouldn't understand, or would raise too many fears, etc. And then maybe 6 to 7 months ago, it was a little more kosher to use it, but still, the new policy was you had to get written permission from the client. So I'd say somewhat slow. And then when I would talk to colleagues, maybe it's just that they didn't want to talk about it because they were scared to talk about using it.
Mm-hmm.
But I also had the sense that a lot of people just weren't using it yet, say 6 or 4 months ago. So that said, I'm in the Salesforce space, like coding Salesforce. I don't work for them directly. And they have big future promises coming soon, we hope. But at least at Dreamforce, the big conference, just a few months ago, a couple months ago, we actually now have Gen AI in our main IDE tool. So you're coding, and there's Gen AI. It's not coding for you. It's you're prompting and asking questions, and it's giving you code you can move over into your main place where you're coding. So it's definitely becoming more accessible. But a lot of the stuff that Salesforce is promising for AI is like kind of coming slow.
Mm-hmm. Yeah, that's one reason why I mentioned I think it's going to be interesting to see what happens in the startup space because, and I only really know this because I've been listening to folks talk about it. And then I've experienced this recently where, you know, because of the constraints that I would say have been literally just blown away and completely removed from the market because of this technology, you know, it's allowing folks like me who I'm not at heart, I'm not an entrepreneur, but I had an idea and, you know, was very quickly able to set up an LLC, create a website, then discover that Microsoft has a Founders Hub program, which makes it extremely easy to get seed funding to basically use all of their services. So, we basically have a platform where we can get access to different API endpoints. I mean, these are all things that would have been constraints a year ago, and they're not there anymore. So literally over a weekend, me and a student, were able to get $5,000 in credits on Azure so that we can actually start hitting the OpenAI API and any of their other services. It's going to be fascinating to see what kind of a creative tidal wave this unleashes, because there don't seem to be any barriers that used to be there. Carol, I wanted to get to your question in the chat. You asked about ethics. I don't have any formal resources on hand, but I'll just tell you, stay tuned and maybe reach out to me. I'm easy to find. At ASU, we're actually right now developing a new certificate program that's going to be launched early next year, an AI in business program. It's going to have 3 classes. One is basically going to be an AI literacy class, then there's going to be a Python class, and then a machine learning class. But the AI literacy class, and I'll be teaching that one, I've got an entire module that is focused specifically on ethics. Basically, how do we make sure that we build and deploy responsible AI that isn't going to cause more harm than good. If you're not interested in the courses, I mean, I'll definitely have a bunch of resources in the next month that I will have pulled together that I'd be happy to share. But we should definitely be thinking about that.
Do you have an opinion on whether, what's it called, prompt engineering is like a thing that's actually a paid thing? We're talking about people making 300K with this.
So I have not seen the numbers on that. If that's maybe I should change jobs. If that's what they're offering, or if maybe that's really effective marketing to try to get people to sign up for a class, right? Teaching people how to be a prompt engineer.
It was in Forbes or one of like the big like business magazines, I think.
Yeah.
And then when I actually go out there and like look for those jobs just to see what's available, it's not quite obvious. Like there's not a whole lot of hits for prompt engineer. However, you would get hits for things that are pretty similar, and it's not really clear if you need to even know how to code or not know how to code. But yeah, apparently you don't even need to know how to code to make 300K.
Yeah, so it'll be interesting to see if there develops an actual market for that type of a title. I do have an opinion about the fact that I think people who actively use generative AI to assist them in their jobs are going to be at a huge advantage. I get that there are limitations. Some companies have said, hey, you can't use this, at least on internal machines with proprietary data. But I've had some folks come to me and say, hey, I work at Intel or I work at Salesforce or this other company. I can't use it on my work machine. I can't use it with my internal data. And my response is, well, can you describe the problem you're trying to solve and the data in an abstract way and have the AI simulate data for you that you could then work with in private to be able to, pursue proofs of concept or ideas that maybe you can't pursue while you're at work. I would say tread lightly there as well. I don't want anybody to get in trouble, but I can certainly see that as a huge temptation. Like if I was in the private sector, I would be doing that in the nights and the weekends, even if I couldn't use it, 9 to 5 while I'm at work. I would probably be doing those things to try to get ahead and try to be more productive. And I mean, because I looking back, I can't tell you how many times when I was in industry, I had so many ideas, and then it would be like, hey, I want to do this thing. And the response was, well, you can't have access to that data. Can you, it would take months, in dialogue with the security team to convince them why we needed to get the data to be able to do the thing that we wanted to do. Well, now I would basically just go to AI and say, hey, here's some hypothetical variables. Here's some reasonable distributions for what I think that data might look like. Can you use Monte Carlo simulation and write a Python script to actually create some hypothetical data for me? So I can then build a proof of concept to go back to my team and say, hey, this is what I want to build. I just need you to give me access to the real data. And at that point, they might look at what I built and say, oh my gosh, that's amazing. We have to have that. Yes, we'll give you access to the data. Please build this for real. But that wasn't my reality when I was a practitioner, but I think that is the reality now. Any other thought? I could talk about this all day, just so you guys know. This is kind of taken over my life, and it's
Yeah. Question, I guess, like, you know, like, right, I have a colleague who's in like a different company now, and part of his business involves, it's like a subscription model, but then it's like physical units that they're renting out, but then they have subscribers who go into default, right? And they essentially have to like repossess this item that they had been renting out. And in my head, I'm like, oh my God, it would be cool to write, you know, try out some models and see if you could predict, you know, default before you get to the point where you're actually, you know, we're like leading indicators, right? Rather than just like, oh, you're late on your bill. And yeah, I can kind of like think of all this stuff, but then like to propose to him, right? Like, hey, check out this project that, you know, I could do for your company. But what about like, I guess, like if they don't have the internal team to like maintain something like that, is that just like always going to be a limiting factor where you can only kind of work with companies that have like the internal resources to like maintain a model, for example? Like,
I mean, I think certainly in the short run, that'll still be a constraint. But again, it's going to be interesting to see what happens with the development with basically these smaller AI agents. So I don't know if any of you follow Hugging Face, which is a big open source community. I encourage you to check it out. I mean, they have folks who are posting and voting on you know, basically models. I mean, they have thousands of models. If you want a model that can do speech to text or text to speech, or you want a model that is focused on being able to, you know, do some sort of prediction that lines up with the application that you just described to me, there'll be a whole host of like, so you don't have to reinvent the wheel. Like all these models are there, and they're basically just different endpoints that you would have to connect to. But you could, in theory, use a large language model to help orchestrate all of that. So all of this is up in the air right now. And you know, theoretically, where folks are envisioning this going is to the point where you could, you know, this technology could end up, you know, making teams much more productive than they could be otherwise. If somebody knows the technology and knows coding inside and out and knows the art of the possible and can describe in human language better than other people what they want the tools to do, in theory, these models could then go find the tooling that they needed to be able to build the thing, but then to maintain it and support it and do all of those things that you kind of just referred to, that right now might take a much larger organization. And I know, as I say that, I know that probably sounds scary. You know, I'll be honest, I don't even know what this means for me. Like, I see what generative AI is able to do as far as education for my students. So I regularly have an in-class activity where I'll give a lecture, and then I have my students go get on ChatGPT and have some dialogue about the topic that we just discussed in class. And and then they have to submit it. They have to take that transcription, turn it in. And I go through those and I see the conversations that they're having with the AI. And it's a really awkward thing for me because I realize, oh my gosh, that explanation that I gave in class, they didn't understand it. I thought it was crystal clear. It wasn't, because I can see the students following up with the AI and asking, asking questions to make sure they understand it. And I read all that and think, I don't know if the students need me. I really don't know if they need me. So this means I have to be thinking outside the box about, like, what's my value add? What can I do that the AI can't currently do? And I think it's in all of our best interest to be thinking along those lines. And again, I know that can sound scary, but that's kind of the reality. I would rather go into this with my eyes wide open than pretending that everything's going to be okay. But overall, I'm optimistic. Like, I'm just so excited with what this technology is capable of doing. So I tend to be more optimistic than pessimistic.
Yeah, there was that quote that was going around, and it's like, AI isn't going to take your job. Someone else using AI is going to take your job.
Yeah. I do think that that's true, at least in the short run. But like I said, in the long run, it's so hard to know because, and again, not to bring up like more, out there futuristic ideas, but I mean, this is why people who are, leading the charge on all of this, the Sam Altmans, the Bill Gates, the Elon Musks of the world, the Mark Zuckerbergs. I mean, this is why you hear these folks regularly talking about things like universal basic income. Why have they been talking about this for so long? Because I think, they don't have a crystal ball, but they can at least reasonably anticipate that there could be issues in the future with employability. But that's not all bad, right? Like, I don't know if you guys saw the article last week talking about Bill Gates, discussing, hey, I think very soon we could be at a point where we all have a 3-day work week, right? In 3 days, we'll be able to produce what used to take us an entire week. But if we can do that while still making the same money that we made before, I mean, who wouldn't want that, right? That's more time to drink coffee, read books, go gaze at the stars, whatever hobbies you happen to have. So, there's certainly positive things that we can look forward to. And I think, again, just move forward with our eyes wide open, keep reading, keep studying, keep pushing the boundaries of our own understanding. And that's really the best we can all do. But like I said, I think you guys are all in a great position. You're women who code. I've already established that AI thinks that it's a woman. So it's probably going to, be kinder to all of you. So Riley, I know are we over or?
Yeah, a little bit, but that's all good. I'm gonna stop the recording now though.